So we've got a spec sheet today for what, at first glance looks like a pretty standard piece of IT hardware.
Right, but it solves a problem that kind of breaks physics, or at least the physics of your average copper wire.
Exactly. We're doing a deep dive on the, what is it called? The NTI ST-1FODVI-SC.
Yeah, it's a DVI extender. And I know that sounds incredibly dry,
Yeah, a little.
but the capabilities here are just wild. I mean, we're talking about taking a video signal and pushing it over 3,000 feet.
3,000 feet. And that's really the hook, isn't it? Because if you've ever tried to run a standard HDMI cable, say more than 50 feet,
Oh, it's a complete disaster.
it's just digital snow.
Mhm.
The electrical resistance is just too high. So our mission today is to figure out how NTI gets a clear picture across, what, more than half a mile?
Yeah.
And why you'd pay over $1,000 to do it.
Well, it all comes down to the medium. This system, it just ditches copper wire entirely.
Okay, so what's it using instead?
Fiber optics, specifically just a single strand of multimode SC fiber.
Huh, a single strand. That's interesting, because usually you see two, right? One for sending, one for receiving.
Yeah, this creates what they call a simplex connection. But the real win here isn't just the distance, it's the immunity.
Immunity to what, like electrical interference?
Exactly, RF interference. I mean, if you're running a long copper cable through a hospital or a factory floor,
It's basically a giant antenna.
a huge antenna, it picks up everything. MRI machines, industrial motors, generators. You get ghosting on the screen or, the signal just completely dies.
But fiber uses light. So it's totally immune to all that RF noise.
Totally. You could literally wrap this cable around a running generator and the picture would be rock solid, not a single flicker.
And that must be why the use cases they list are so specific. You're not using this for your home theater.
No, definitely not. It's things like medical imaging, military and aerospace, industrial traffic control.
Environments where you absolutely cannot have the screen flicker for a second.
Yeah, you can't just say, hang on, let me jiggle the cable when you're looking at a critical medical monitor.
Right. And the spec sheet also mentions the form factor is surprisingly small.
Oh yeah, they're tiny, about 1.6 by 2.6 inches. You can just tuck one behind a display or snake it through a conduit pretty easily.
Okay, but let's dig into the specs a little more because there seems to be a huge engineering trade-off hidden in the numbers.
Ah, you're talking about the bandwidth limitations.
Yeah. The marketing says transmits up to 3,280 feet, which sounds incredible. But you don't get full HD resolution at that distance, do you?
No, not even close. It's a sliding scale. If you push the signal, the full 3,000 feet on, say, a 50-micron cable,
your resolution drops way down.
Way down to 1024 by 768.
Which is, what, XGA? That's fine for a highway sign that says traffic ahead or some simple text, but...
You're not watching a movie on it.
No.
To get that high-quality 1920 by 1200 WXGA resolution...
You have to shorten the leash.
Significantly. On that same cable, you're limited to roughly 980 feet.
Wow, so that's a huge drop. Still impressive, but it's a third of the maximum distance.
It is, although what's interesting is if you swap the cable type to 62.5 micron fiber, you can gain some of that ground back.
You can go further.
A bit, yeah. You can get that same high resolution at about 650 feet. It's this balancing act you have to play.
So you really have to know your exact distance and resolution needs before you even think about buying.
Oh, absolutely. This is not a one-size-fits-all solution.
And something else that jumped out at me here was this feature called EDID learning. What exactly is that?
So ED, it stands for Extended Display Identification Data. Think of it as a digital handshake.
Okay.
Normally, your computer talks directly to the monitor and asks, hey, what resolutions and timings can you handle?
Right.
But with an extender in the middle, the computer is too far away to hear the monitor's answer.
Ah, so the NTI unit listens to the monitor first, and then it pretends to be the monitor for the computer.
That is a perfect way to put it. It memorizes the answer. It tricks the computer into thinking the display's plugged right in so you don't get that dreaded black screen on boot up.
Which, for a remote system, is absolutely crucial.
Yeah.
Speaking of reliability, the MTBF number is just staggering.
The mean time between failures, yeah, what was it again?
It's listed at 91,952 hours.
Wow. That's what? Over 10 years of running continuous.
Over 10 years. And I think that right there explains the $1,000 price tag.
It has to. You're not paying for the little plastic box. You're paying for the decade. You don't have to climb a ladder in a stadium to go and replace it.
It's the install and forget tax.
It really is. It's class 1 laser safe. It's low power. and it just sits there, pulsing light through glass for a decade.
It really changes how you look at public infrastructure. So next time you're at an airport looking at the flight board or at a game looking at the scoreboard, just realize there's a good chance that image is riding an invisible laser beam through a hidden glass thread that could be half a mile long.
And that without that single fragile thread, the information we rely on in that moment just stops.
An invisible backbone. It makes you wonder what other invisible tech is holding our daily world together. Something to think about. Thanks for another great deep dive.
My pleasure. Talk to you next time.